Human milk oligosaccharides are complex sugars, carbohydrates that are found uniquely in human milk. They're at very high concentrations that often exceed the concentrations of human milk proteins. And the question now is, why does mom make these oligosaccharides and what is the benefit for the infant? The variety of oligosaccharides really gives us a tool to understand what the different oligosaccharides do. So our approach is to do preclinical studies like everyone else is doing, use animal models, use tissue culture models to see, do oligosaccharides have an effect? And if they do, can we identify which structure is responsible and do real structure-function relationship assays? So if they work as prebiotics, can they change or alter the dysbiosis we see in the context of obesity and inflammatory bowel disease? Can we interfere with some of these natural oligosaccharides that we found in human milk and use that for the adults to have a direct effect on the gut microbiome as they serve as prebiotics? Can we use them as anti-infectives in the context of GI infections, diarrheal infections, and other potential mechanisms? Also, they may have anti-inflammatory effects that change the immune system and modulate the immune system and may have a benefit for other age groups as well, not just the infant. Necrotizing enterocolitis, which is a disease that affects preterm infants. And so this is a disease that affects the preterm infant gut, and about 5 to 10% of the very low birth weight infants get affected by necrotizing enterocolitis, and a quarter of them die. So epidemiological data shows that breastfed infants are at a much lower risk to develop this disease. And the question is, what is it in human milk that protects from necrotizing enterocolitis? And we found in preclinical models that it is potentially oligosaccharides that contribute to this risk, or reduced risk. We've now shown in both in preclinical studies and also now in new cohort studies that come out that is one specific oligosaccharide that seems to be beneficial in this context. The power that we have here with human milk is that we can do mother-infant cohort studies where we can really look what is the oligosaccharide composition and how do these oligosaccharides correlate with infant disease outcome. So most of our work is in the context of the infant. So what do HMOs do and how do they benefit the infant? But we can envision that similar mechanisms also benefit the adult. Can we change arthritis, atherosclerosis? Do we have a specific oligosaccharide that correlates with a specific infectious disease? And if that's true, and we can overlay those data sets from preclinical studies and from the cohort studies, then that is very informative to move forward with clinical studies, to lower the risk between preclinical studies and moving forward to clinical. The most exciting part of the work is that we have a natural matrix that provides these compounds that have been evolved over the last 1.52 million years. We know they're safe for the infant, and can we use those compounds now for the adult to build something around this natural template that is then safe but also very efficient for different diseases? I think in the next 3, 5, maybe 10 years, we will see that more and more of these oligosaccharides will become available, so the real oligosaccharides that we find in human milk. And we might see them as a supplement for infant formula, but we might also see them on the shelf as supplements for the adult in different disease contexts that might change inflammation, be specific prebiotics. So I can see a lot of potential for these oligosaccharides in the future.